All right. Thanks everybody for joining. So this is Dallas Meetup group virtually. So you can join from anywhere. So we have today's session, we have Matt McLarty. So he's going to present about API microservices. So if you guys have any questions, please jump in or we can ask it at the end as well. Matt, I'll let you introduce yourself first.
Sure. Thanks for the opportunity to be here. My name is Matt McLarty. I'm the global leader of API strategy here at MuleSoft. And I like today's topic because I think for the last couple of years, I've been focusing heavily on the business strategy side of APIs. Nevertheless, I've kind of maintained my roots around architecture, enterprise architecture, especially around APIs and microservices and how everything fits together. So I love the idea of talking about microservices. Before I joined MuleSoft, I led a group called the API Academy, and one of the things we did was publish a book for O'Reilly. I'm representing O'Reilly, I guess, in 2016 on microservice architecture. So it's a topic I've been tracking for a while, and that's actually going to be. I'll do a short talk. The theme is really around kind of looking back. If you can believe it, we're 10 years into microservices, which is kind of amazing to me. So do you want me to go ahead and share slides or anything else before we begin? No, it's good?
Yeah,
Okay, cool. So, like I said, we're going to talk about a whole decade of microservices. So it was actually the origin story of microservices. Well, we'll talk more about the real origins of microservices, but the term, the kind of identification that there's this new pattern and paradigm happening in software engineering was at a software architecture conference in Venice in 2011. So I think it was a little later in the year. So we're not exactly at 10 years. But this is where a group got together. I think quite a few people from ThoughtWorks, including James Lewis, were saying, yeah, we're starting to see this pattern where especially companies that were started out kind of in the web native space and were building these big applications where they were moving really quickly were kind of hitting a threshold where they found they couldn't really scale their delivery anymore. It wasn't so much about they couldn't scale their operational runtime systems. It was more a case of they didn't feel like a startup anymore because they felt like it took too much coordination and time to try and put new features and releases out. So to tackle that problem, they wanted to break things down into smaller bits, and that required kind of a holistic change in how they did things. And so this pattern was kind of observed, say, hey, what do we call this thing? And it was James Lewis, I think, in 2012, who started going around giving talks at conferences using the term microservices. I think he might have hyphenated microservices initially, but eventually it landed on this one word blob. So, I personally, though, think that there's a lot more to the origins of microservices than just that software architect conference, right? And especially, it wasn't just about web native companies trying to come up with ways to scale their delivery. I think that if we look at all the big trends that we're dealing with in the IT space and the software engineering space, they've all had this goal of kind of dealing with the complexity of these mass integrated software systems that keep getting bigger and bigger and more complex and more sophisticated. And so we've had agile movement to kind of deal with the methodology around the bloat that happened when projects got too big and people who were delivering them got too far away from customer inputs and the feedback loop became too wide. Really, that's what agile is about. And then we kind of, once we start removing the bottlenecks around the development methodology, then we run into this challenge of the problems that happen when we get these big silos of development operations, and that creates issues around resiliency of systems and quality and so on. So that's kind of the DevOps movement. And of course, we do have this issue of flexibility in the runtime environments, development environments, and elasticity and scaling the kind of operations of applications. That's where cloud comes in. And even historically, dealing with the challenges of enterprise software complexity, we had service-oriented architecture. And in the midst of all this stuff, we have APIs, right? And APIs is a concept that is very old and still sort of relatively new. It's old in the sense that as developers, we've been using APIs for 50 years, whether it was to access procedures in COBOL code on mainframes, all the way up to now providing, gRPC and GraphQL endpoints. But I think most universally we think about APIs as web APIs with RESTful interfaces. But all of these are factors that kind of contributed to the whole microservice architecture movement. And that makes it a bit challenging because it becomes so big, right? When people refer to microservice architecture, you see a lot of literature out there talking about what is a microservice? How big should a microservice be? Like, that's a little bit beside the point, because microservice architecture, and when people generally talk about microservices, it's this all-encompassing thing that covers culture and all the way from culture down to the lowest levels of technology. So, I'd say the watershed moment for microservices was when Lewis joined up with Martin Fowler to make this post on what Fowler calls his Blicky, to define this new term, microservices. And it was pretty impactful, right? Here's the Google Trends for the search term microservices going back to when, 10 years ago. You can see that little blip when things start trending up is when that blog was published, right? Defining microservices. All of a sudden it took off. And I can tell you that at the time, as somebody who'd been through years of SOA and had been immersed in APIs, my initial reaction was like, what's all the fuss? It feels like SOA again, like it's repackaged SOA. But I kind of tried to open my mind and erase my biases and read the Blicky, got into it, and it's something that I actually go back and read quite frequently. I think the Fowler-Lewis post on microservices is extremely well written and covers a lot of areas that I see as pretty timeless when it comes to software engineering. So the way that post is structured, I'm not sure if everyone's read it, but they really talk about these 9 characteristics of microservice architecture. Rather than taking a purist view, like we went in a laboratory and invented microservices, here's the formula, right? It was very much, here are the patterns that we're seeing around these companies that we would say are doing microservices. And these slides visually, I apologize, these are probably going to be the least visually interesting slides that you'll ever see, but I'm going to try and be very animated and make sure it's entertaining. But I think it's worthwhile for anyone who is in an environment where you're looking at microservices or implementing microservices, or maybe feel you implemented microservices, to go back and look at how it was defined. Because if you don't, right, if people just take bits and pieces of microservices and say, well, we're gonna containerize things, and that's microservices. If you only take a piece of it, you're not going to get the full benefit. And I think the goal of microservices around providing that agility, providing that manageability, and especially optimizing software systems for changeability over time, I think that's the ultimate optimization point for this architectural style. If you don't do all of this stuff, you won't be able to achieve that. So I won't go through this full list in detail, because we're gonna go through each one. So I want to kind of look at what Fowler and Lewis said about microservices, and then where I see us today. So they talked about this idea of componentization via services, probably the number one characteristic. At that time, they were talking about, look, people are getting away from doing libraries for sharing functionality, because If you share libraries all over the place, you bind it into code, it becomes a lot harder to change, and it's too easy for things to bleed together, and you don't have a real strict boundary between what the shared functionality is doing and what your core application is doing. And they were talking about network boundaries as being a fundamental part of the picture. I mean, what's funny about this is that it mimics exactly the legendary Jeff Bezos mandate at Amazon, saying everything needs to be built behind service interfaces. I don't care what they are, but there has to be a network boundary. So it feels like that was kind of maybe coming out of the Amazon mantra, but here it was in this Blicky post saying this is what we're seeing. They also talked about the importance of explicit interfaces, right? That instead of things being too commingled, really taking time to define interfaces for functionality as a decoupling mechanism, right? And the need for independent deployability was a big deal because you needed to really free up and enable continuous delivery as a mechanism for getting features out the door quickly. So there's an operational element there that if you were able to break things down into smaller services, then it would make it a lot easier to implement small changes. And when you implement small changes, they're lower risk changes. I think one of the patterns that we'd seen in the monolithic world was, and I experienced this through the early 2000s, you get a big release, it's filled with risk, it doesn't go well, and then all the ops people and executives say, change is really risky, we're going to clamp down and we're going to put gate reviews, we're going to really scrutinize all these changes coming through, which leads to more fear, more bigger releases, less frequent releases, and then things fail again, and it creates this vicious cycle. So the idea here is break things down into smaller bits, then we'll get a lot more operational resiliency because we're not going to be, we're going to have very low risk changes. And this is very much part of the DevOps philosophy, but here's an architectural style saying, well, if you want to do what DevOps is promoting, here's the way you can do it, breaking it down into these small bits. And I think it was really interesting going back in that post that, the service, they already had this idea that a service doesn't necessarily mean it's a single process, right? The service could be a collection of processes, but they have to have a strict kind of boundary. Apologies for my annoying doorbell in the background. So where are we today? We have, we've come a long way here. We've come up with a ton of different ways of componentizing via services, right? We've seen Docker rise as the big thing and then kind of fade and be replaced with Kubernetes because it's like, well, containers are a commodity now. It's container orchestration that's the big deal. We've seen the rise of serverless come up. If it's not small enough to have containers, what about Lambda functions and so on? Well, I've seen companies kind of struggle with this idea that, the process is not, maybe the process could be part of a microservice. And I've seen people even struggle with, how big is a microservice? What is a microservice? And all this interesting debate about mesoservices and nano services and mini services and it goes on and on. People really maybe get over rotating on the micro prefix. And we've seen then this idea that, well, wait a minute, if we're going to break things down into smaller bits, we still have a need to aggregate things sometimes. We've seen the backends for front ends concept coming out of I'd say the kind of the core microservice community. The idea that you would have a way of aggregating the services that you need for particular front end uses. And we've seen GraphQL rise up as the new standard. And a lot of the pitch of GraphQL is saying, hey, here's a way to aggregate services. So I think that the reason that we're, there's a lot in here, but I think the reason that we're seeing that is there's always this push and pull, right? As I said before, microservices as a style is optimizing for changeability over time, but there's lots of different things to optimize for. And so you will get contention. If you want to optimize for front-end user experience, there's going to be some contention with the optimal architecture for how you would make things as agile and changeable as possible. And I think that's the job of architecture, is to really be able to, make the right decisions around those points of contention. So one of the things, though, I think that that comes out of this as well, though, is we see a trend that happens in IT, which is people get obsessed about kind of the underlying infrastructure, and that causes them to sometimes lose sight of what's important, which is actually what you're building. What are the services themselves? So I'm hopeful that we will keep focused on services and recognize that our goal is really to deliver services that fulfill customer needs, user needs, and not assume that if we implement Kubernetes everywhere, for example, we've somehow accomplished something, right? We haven't really accomplished anything until we've got those services on and we've got customers satisfied. So that takes me to what I think is a fundamental characteristic that Fowler and Lewis put in, which is the organization around business capabilities. So what they're saying here is, look, historically in the monolithic world, we might have organized groups, organized libraries, organized our modularization of our applications around these horizontal functions. Like, here's the UI layer, here's the kind of business functionality, here's the data layer, and got these tiers and teams of experts who had shared expertise from a technical standpoint. The trend they're seeing in these companies that did microservices was to be more cross-functional, be more focused on vertical slices of functionality that matched particular customer needs, particular user needs, right? So that you would have the product manager and the architect and the developer and the ops person who are all supporting these slices of product function aligned to business capabilities. Now, they already kind of had this idea too, that you again, one of the anti-patterns I've seen in microservices, people can go too deep, too low on how they break things apart. So even though they're called microservices, if you go in and try and split every data entity into its own microservice, you actually could be overdoing it, right? And it's actually easier to split a service than it is to amalgamate services. So that's just kind of a rule of thumb. As you're breaking things down, don't be too aggressive on going to the lowest level, right? Break things down as needed. Break things down in a way that allows you to split the teams and reduce coordination between team activities. But again, I think the lesson here is really teams and, sorry about that. I'll take 1 second, and you'll never hear that again. Just a sec. So sorry about that. This is what happens when we get sun in Vancouver in February. It's so unexpected. It causes our automated systems to go wild. Okay. So I think one of the things that they called out as well around business capabilities is that when you're looking at team size, there should be a real harmony between the size of the team and the size of the service. And in fact, organizationally, they would argue that team size is more important to preserve than service size. So you could have a team supporting 5 microservices. If those services get too much to manage, then rather than split the team or amalgamate teams, you'd probably hand some of those services off to another team or split them in a way that they could be built by other teams. But anyway, where I've seen this kind of impact us in the last several years, this is, I think, why there's been such a resurgence in domain-driven design. I think that as an industry, we have not done a great job of providing methodologies that allow us to design software, to architect software that matches this notion of business capabilities being the first filter, right? If you look at most architecture diagrams now, you'll see a lot of boxes and arrows and maybe protocol names and maybe even, vendor application names. It's hard to get a picture that shows you from a business standpoint what are the actual capabilities involved in particular user interactions. This is a big research area of mine. In fact, I think my last 2 blog posts have been focused on how do we come up with a visualization scheme that allows us to do this in a more business-oriented and technology-agnostic way. But domain-driven design at the high level provides that, and I think that's why it's become popular as a way of people understanding how they can break down the problem space into business capabilities before they go and worry about how they implement it. We've seen the Spotify model become popular as an organizational framework. If you're not familiar with that, that's the squads, tribes, guilds, where you would have cross-functional squads and then guilds as a way of sharing special interest areas across organizational units to incent communication there. That's kind of had some holes poked in it as well, though, by ex-Spotify people who say it's all a lie. But I think notionally, what's important coming out of that is, yes, we need to have these cross-functional product teams. That seems to be the right way to optimize. But you also have to have ways of driving communication across the organization. Because again, if you are an extremist in the optimization and go exclusively to independent product teams, you can start to silo things in a different way, and that becomes problematic. Lots of debate about, like I said, about sizes of microservices. Again, my opinion is it's all about the harmony between having those small cross-functional teams and what they're able to support from a service standpoint. And in the enterprise space, when it comes to microservices, we've seen lots of struggles around business versus IT, which is very split at a high level. It becomes political. It's hard to form those cross-functional teams. But even in some of the longest established companies I've been working with, starting to see this happen. Even if it's not a direct reporting line teams, they're getting cross-functional teams together for temporary assignments and which can turn into long-term assignments as an optimization mechanism of the organization. So moving into the next one is products, not projects. I think this is a
quick question about that last piece. One thing that I didn't see, and this comes up a lot in my conversation is, maybe regarding componentization, or maybe is around the structure of the teams, is how much independent should the teams be each other, right? If I own a service, then do I have the liberty to go and pick my own database, all the way down if that's what I need? And, now the other teams building a service, do they go out and do their own thing? Is there a play for a shared, whether it's infrastructure, database, what have you, down at the bottom?
Yeah. So what I didn't talk about is generally in the most mature organizations that have this model, they'll have a group of platform teams who are a shared resource, not necessarily enterprise-wide, but there may be multiple platform teams. But their job would be to provide the tools for the product teams to go and build. And this is true in Netflix. This is true in Amazon. What they do, though, is they try not to, I think when it's done well, there are standards, there are common ways of doing things, because again, optimizing on a different level, as much as people talk about polyglot as a property of microservice architecture, if you have 50 different platforms and 50 different languages and so on, it becomes suboptimal just to manage.
Right.
So, but what they do is, rather than say, here's the standard for the enterprise, go and do it or else you're going to be in trouble. Right? They say, here's a toolkit to use that's going to make your job easier to go and build services, right? And here's the training on it, and here's the person to call for help. So they take more of that service mentality to enable the cross-functional teams. And I have worked with other, like there's a whole discussion to be had on standards, but I've worked with some companies who have said, we don't standardize anything, but we provide lots and lots of tooling and capabilities for particular technology sets. And what happens is naturally, it's the carrot, not the stick. People in the organization tend to just adopt those, use them, and you get that reuse at that level. There may be some exceptions, but for the most part, they're following that approach. So that's the pattern that I've seen. In terms of ownership of data, I'll talk about that in a bit, because I think that is a big area of friction with the whole approach. And I know I'm eating up a lot of time with the talk. I'm talking too much here. At least I got rid of the chime. So I'll skip through the next few a little bit quicker so we have more time for discussion. So products, not projects, they put it into microservices. This is clearly an agile principle, right? So I'm sure Fowler is like, we better put this in there, reinforce it. But this does follow the whole you build it, you run it mentality. That was a big hallmark of the Amazon mantra. This is really about, again, reinforcing that business alignment, saying you got to focus on user needs, and really this is the essence of agile. So I think one thing that dovetails nicely with the API topic is we talk a lot about APIs as products. And maybe the number one thing to consider here is, from a design perspective, always think putting yourself in the consumer's shoes. So the same principle applies to both microservices as well as APIs, I think, where don't try and go inside out and say, well, we want to create a microservice for this particular data entity, so we're going to create an interface that has everything in it and so on. Really be thinking about the usage patterns and consumer needs. And sharing information should be more on a need-to-know basis than just information hiding has been a long-term software engineering principle, because it incents more evolvability, it makes change management easier, and it just makes the developer experience better on the other side. So lots of agile adoption happening. However, in enterprise context, I still see lots of struggles where people adopt. They say they're going agile, but they kind of miss the principles of agile. My sister works at a bank where I used to work, and she called me one day and said, "Oh, we're going agile. They've removed all the chairs from the meeting rooms. Don't do that. It's not about having stand-up meetings, right? It's not about the ceremony of agile. It's about the real core principles." So, but there are legitimate challenges to this type of ownership style. Like, there are certain industries where you've got regulatory needs where it's hard for a person who's the hands-on developer to be the person who's hands-on the production environment, right? There's separation of concerns and so on. But I would say also the number one barrier in enterprise to getting to this more agile approach, getting to this more flexible approach of having teams select what type of work they're going to do and having dynamic product backlogs is the way budgets work at enterprises, right? There are a lot of them are long-term plan-based organizations, and that's not a good fit. So that's a hard one for techies to solve, but it's a barrier to be aware of. Now, here's one that probably, as in MuleSoft Meetup group, is an interesting discussion point. They brought up the whole smart endpoints and dumb pipes idiom, which came from the Unix principles, as a, hey, we this is what we're seeing in the microservices space. Now, what they meant by this is, like, don't put complex business logic in the middle. That business logic, complex logic, really belongs as part of the service. And this was 100% a reaction to how SOA had been implemented 10 years, 5 years prior, right? I think it's either Fowler or Lewis did a presentation called, I think it was Lewis did one called, "Does my bus look big in these pants?" or something like that, talking about bloated ESBs, and Fowler talked about ESB meaning egregious spaghetti bus. So they were pretty clear in their opinions, but I think it is a very important point, because I lived through that as well. And I think, yet again, there's this affinity between the technology implementation and the teams. The SOA era was kind of a lot of big integration factories at enterprises where everything was being stuffed in the middle to deal with integration problems. And what that caused was teams that didn't have the business domain expertise, writing stuff, maintaining stuff, creating a bottleneck for future projects, and it just created a bad dynamic in the organization. So again, going back to boundaries, knowing that business logic belongs in the service is important. And I think as you look at our MuleSoft's API-led connectivity approach, it's clearly part of that picture, right? To say even further, let's talk about the different levels of services that you might have in your environment and where some of that functionality belongs. So I think, in sophisticated environments, having the ownership of the services with the business logic, with business domain experts is key. But there's another, I've seen this misused, right? I've seen lots of companies over-rotate on this idea of smart endpoints and dumb pipes and start to think nothing belongs in the middle, right? That I actually worked with one very large, very well-known company in the US, who I won't name, who was like saying, we're going to do microservices. We're going to pull all of our network router logic into the services because we don't want to have smart pipes. Like, hold on a minute. That's not business logic. So what's good, though, I think that has evolved since 2014 is that we're getting smarter about this notion of data plane versus control plane, that there actually is a lot of complexity that can happen in the switching the network pipes side of things. It's just that it needs to be the right logic. So system-wide stuff like security and routing and observability, these are not things you want to have baked into each service, right? So having a way of providing system-wide functionality in the pipes is important. And I think this is why service mesh has become really popular in the microservices community. I think to a degree, it felt like the microservices community was discovering some of the value points that we were, MuleSoft and others have been providing through middleware, had been providing for years. But that also has led to sort of a needless debate around service proxies and API gateways, where the important thing is you have these system-wide capabilities that are needed, and you're going to have different points of enforcement, right? Service proxies in a case of maybe a container-based cluster, API gateways for external facing or for API enabling certain application componentry. The same will apply for asynchronous communication as well, which is why, brief product plug from me, I think why we're positioned so well with our platform, because we're able to handle all of those scenarios. Decentralized.
Hey, Matt.
Yeah.
If you don't mind, I have a question on the previous slide. So it's interesting you got the point of like service proxies, APIs, and this mesh, right? So generally what I've seen, and I think theoretically as well, people building microservices end up with so many of them. It becomes like so much hassle. Not just the microservices, even the proxies, right? So I've seen like people putting a proxy for each and everything, maybe not required, maybe it was required at one point of time, but once it is there, it's never removed, right? So how do you handle those kind of situations, or is there a recommendation?
Yeah, I think I would probably start by looking at the services and asking the question, why are there so many services? Right. I think that can happen organically. I think that I'm stereotyping, but I think a lot of microservice environments are still too caught up in the emergent design idea. And quite frankly, just not designing things. I'm building on a need to know an as needed basis. Like Uber is an example of that, where they ended up with, I think, more microservices than they had employees. Right. So and then it was like, well, this is chaos. We almost have to start over again. So there's probably work could be done so that you don't get that sprawl of services. But I think it is a legitimate deployment pattern that for each service, you have its sidecar proxy. I think that's actually a valuable deployment pattern, because you kind of get the best of both worlds. You get the separation of concerns of having your control plane logic in the sidecar, but you also have the distributed deployment. So if you have decent service discovery mechanism to abstract all the services, then that can work okay. But it's probably, I think it probably starts, the problem probably starts with designing up front, thinking through what services are really needed.
Mm-hmm. And do you recommend like going back time to time and checking if this service really adds value and taking out of it if it doesn't add value?
Yeah. I think that there's a whole portfolio management, portfolio governance function that I recommend that is often lacking in organizations, right? Who's looking at the portfolio of services and APIs and measuring exactly that? What's being used, what isn't being used, what's redundant, what can be amalgamated. And I think that, again, it goes back to design. You can design for things to be more mergeable and more easily deprecated, but if you're not doing some thinking up front, then it becomes a big problem. It becomes a big landfill of technical debt. Right?
Then a question from Sridhar. Can you please elaborate on service proxy versus API gateway?
Sure. So the way I see it, service proxy is something that's come out of the service mesh idea. Envoy proxy, what I call a service proxy. I would say to distinguish them, service proxy is typically something that would be deployed as a sidecar container in a container-based environment, probably integrated with some service discovery mechanism or service mesh control plane like Istio and so on. API gateway is a bit more the component where you're providing north-south access to API functions. But I've seen a lot of debate with organizations saying, do I need an API gateway if I have a service proxy? Do I need a service proxy if I have an API gateway? I think that the important thing is first to consider what capabilities are you actually trying to implement, right? Do you need access control? Well, yes. The type of access control you need is going to be different depending on who your consumers are, where you are in the infrastructure and so on. Do you need dynamic routing? Do you need rate limiting? Like there's a bunch of capabilities that have been packaged into API gateways and into service proxies. But that, you start by figuring out what you actually need, and then you can figure out, given the realities of your application deployments, what's going to fit where. I think most enterprise environments will need API gateways. Environments where you've got widespread container deployments, then you may want to have service mesh and service proxies as well.
We do have one more question from Murthy. Murthy, thanks for joining, by the way. So Murthy is asking, does microservices contradict drive principles of software development? And if you have any best practices that you can share, how to leverage commonly used libraries still conforming to microservices architecture?
Sure. Yeah, I think that, again, I think that we, like the way I look at it, software engineering principles are generally rules of thumb. They're like guidance, even if they're stated emphatically as truths, right? We don't really have any axioms in software engineering the way we have axioms in mathematics, right? So drive principle, I think, was that one of the Bob Martin ones? Like, I think it might be, right? So he tends to state things as kind of the word of God. But I think that was more of a rule of thumb, right? Like, where possible, try not to repeat yourself and try not to duplicate things. Just like there's been a, hey, anti-monolith feel to microservices, there's been an anti-drive feel to microservices. People have written blogs like saying, repeat yourself, down with the drive principle. again, it all comes back to what you're optimizing for. So I would say microservices as an architecture is clearly promoting reuse of components, right? We're going to bound things appropriately so that if you need the account info service or the order service, here it is, use it, right? That's kind of repeating yourself, right? You're not writing a new inventory service every time you have a new customer use case. I think what they're wanted to get away from, though, is where trying to overemphasize reuse slows things down. When I've seen people fight against the dry principle in the microservices world, it's been based on saying, I don't want to wait. If I have to wait and coordinate and I get blocked because I am dependent on another team, then that's a problem. So I'd be better off repeating myself. There's little hybrid things too. There was a really interesting blog recently talking about Amazon's approach to this, where Amazon is very independent product teams, but what they'll do when they have a dependency on another team, they may have a need for that team to make changes to the service to fit their needs. So they need an update to the service. Rather than wait for that team to develop it, they have an agreement that people can check out the code for that, make the changes themselves, deploy their own kind of instance of the service, and then that product team will incorporate the change at a later date over time, kind of like a eventual consistency of code. So I think, again, it all comes back to this balancing act of getting the most benefit you can out of the reuse and proper organization of services without slowing things down by the need for having dependencies cause too much coordination need. But unfortunately, like I said, there's no axioms like math, so we can't just say, dry principle trumps everything, or ACID, or whatever our acronyms are. They're just guidelines.
There's one more question from Anoop. I think this is the same point we were talking about earlier regarding, so he's asking, basically, using microservices will have separation of concerns and it's all simplified, which makes developers' life easier. But I've seen it bringing complexity to the infrastructure and maintenance. What is the suggestion to mitigate this?
Yeah, I think it's a great point, right? I think it's like this is one of those almost physics principles that complexity never goes away. It just moves. Right? So again, this goes back to what are we optimizing for? Well, it's definitely a architectural style that's optimized for developer experience. So specifically developers who are building the services, right? I think one of the big pain points was, if I'm dealing with a monolithic code base, then I've got, just a lot more of a headache for me to check in changes and regression tests and so on. But yes, absolutely, you create a more complex operational environment. I think that what helps there is something that can be lacking, right? Which is whether you're consciously adopting a microservice architecture or not, most organizations are going more and more distributed, and that is a more complex operational environment. And I think that one of the things that goes away if you move from a monolithic architecture, that kind of comes with platform system management, right? So a lot of times in monolithic environments, you'd be relying on a single app server platform or something like that to do security and monitoring and so on. So number one thing is, I think you need to start thinking about managing distributed environments differently than managing monolithic environments. Unfortunately, a lot of the tools we use for operational management are still based on low-level system components and platform thinking and so on. I think it's in a distributed world, we kind of follow the principles of complex systems management, which we're very much more focused on the interactions between the distributed parts, right? So we're going to live more with failure. We're more distributed. There's more moving pieces. we have to be better at living with failure. So rather than focus on making sure nothing ever fails, we have to be better at dealing with failures efficiently, right? And isolating failures. And that's why the interactions become more important. So I think the operational focus to help deal with that complexity that moves starts with, can I see the system? Can I see everything that's there? And I think this is where APIs become really important, because if you just start spreading things all over the place and you've got a bunch of different ways of interacting between systems, it's really hard to see. If you actually normalize the way you integrate your components through APIs, that gives you a consistent place to enforce security policies, to consistently monitor interactions, and enforce policies even at the API layer. So again, I think that's a big value point from my perspective on our platform, in how it can see the distributed world and see it at the right level where you can actually start to observe that stuff. But it's a really interesting and evolving space, and I think that because it wasn't the focus of the optimization and that led to the architecture, it's still something that's developing the practices around that. So I know that I kind of had see if I'm loving the discussion, so I'll see if there's any more really important points to make on the subsequent slides. Decentralizing governance this was really about making sure that you're allowing some independence in those teams, allowing decision making to happen within teams, not being all top down and one way in the communication, but more pushing power to the edges of the organization and then facilitating communication between them. So that's something that I think is still a bit of a struggle for organizations who still have a tendency to want to think top down. From our perspective, kind of a big reflection of this is in the SOA era. There was a lot of COE thinking, central, empire building in the center of the organization. We talk about C4E, and there still needs to be that central push, but more of an enablement mentality, a service mentality of teaching and facilitating communication as the fundamental goals of central governance efforts. Data, I talked about this being kind of a contentious one. I think that there was this, again, we always like to follow extremes. People got really hung up on isolating data within microservice environments. At the same time, I think what's really interesting is at the same time microservices was becoming so popular and evolving, we had this movement to organizations having, moving from data warehouses to data lakes, saying like, let's get all the data we have anywhere and collect it in a place so that we can start running these big complex analytics on it, kind of work against each other. But I think that some of the principles that were put out around eventual consistency, recognizing that there really is no good way to enforce distributed transactions, that's just a failed model based on on our now decades of experience trying to do that. I think it was an important piece. So, but I think this is a really interesting area to look at from an API perspective as well, because the next big, or one of the next big trends that ThoughtWorks is working on now, and I'm hoping to have one of the ThoughtWorks leaders in that space, Shamak Dagani, on our podcast soon, is this idea of data mesh. So the same patterns we went through with monolithic applications, we're starting to see that happening with monolithic data warehouses and data lakes, moving to a more distributed data infrastructure. And I think APIs will play a big role in that. So infrastructure automation is kind of an obvious one. This was really more of the prerequisite statement from Fowler and Lewis saying, look, if you want to do microservices effectively, you've got to be automated in these areas of testing and deployment and operations. Otherwise, you won't get any of the benefits, because you can code really quickly, but then you're going to be waiting months on the testers, right? So I think this has been probably the easiest transition because organizations are already moving down this path. But it also, in my opinion, if people get on their cloud native journey and they put in all the technology bits, that's not enough, right? You still need to do all those organizational and strategic steps, applications. So I think though what we're seeing now is, again, to the last discussion we had, that it's great. We have lots of ways to automate, but the more sophisticated the infrastructure we put in, the more complexity we have to deal with there, right? So there's this knock-on effect of, well, we've got this fantastically distributed infrastructure. How do we manage that, right? So you can create more complexity out of that. So it's, I think, again, always going back to thinking about what you need, even when it comes to technology capabilities. What do you need? I worked with a customer not too long ago who were very excited about their Kubernetes implementation that they were going through. And like I asked them, like, what's the rate of change in this application environment? What are the volumes? It just felt like a complete over-engineering to have this massively dynamic container orchestration system for an application that I think had like less than 1 transaction per second at peak. So anyway, it's always a matter of figuring out what you need, because the more sophisticated stuff you introduce, the more complexity you're going to deal with. And then a big principle around designing for failure. This is actually the one that we just talked about. I think this is the biggest mindset shift for people in operations, getting away from thinking that you can stop things failing to recognizing that things are going to fail all the time in distributed environments, and looking at how you can appropriately deal with those failures. What do they look like? How do you isolate them? How do you minimize the impact? Because again, I think if you're optimizing for changes and frequent changes, it's really important to be able to deal with failures. And I think all, we've kind of learned the lessons around some of the things that can cause problems, like shared libraries. I think this is where service mesh thinking is really kind of, and API gateways help in this regard, not only from an integration standpoint, but from an operational standpoint in distributed environments. And I cite the book Accelerate here, which is a great book that was kind of like a scientific study of good software engineering practices that I recommend. All right. And then evolutionary design is kind of something I've hit on all along as the big goal, where breaking things down into smaller bits, being more experimental. I just want to leave a couple minutes for more questions. I can go longer than the end of the hour if others can as well. But I think they, in looking back at that post from Fowler and Lewis, it was so well written, and I think it still applies. And I think the industry is still in big pockets moving towards what they're talking about there. They didn't talk a lot about security, and I think that there are specific security concerns around moving to a microservice architecture where you're creating more potential vulnerabilities. It's important. The idea of cross-system capabilities, so what needs to be shared, what are some of the challenges of operating distributed environments? They didn't really cover that too much. We've talked about it. And they didn't talk a lot about the fact that even though you have these independent teams, cross-functional teams, you still do need those groups and functions for things that matter to the overall organization. We talked about some of those in the operational environment, as well as standardization, consistency, things that are going to matter to the end users of the systems. Where, because one of the risks is you put in a bunch of microservices and they're all so different that it's a cognitive overload for your consumers. Like if I'm using the customer information system and then I go to the order system, it's so different that it doesn't make sense to me. There's still a need for these cross-organizational functions. And front ends are an area where there's been a lot of debate as well. We've seen movements like the SCS, can't even remember what it stands for, where they're saying, have micro front ends. My personal opinion is I think front end should be optimized for user experience, which doesn't necessarily match the domain modeling on the back end, so they need to be separate, but it's still an area of debate. this was my plug where I was going to talk about how Martin Fowler had quoted me on his page. Then I went and checked the page yesterday and it's gone. So I have but a screenshot of a past citation of one of my articles. So if you want, I think the best stuff for microservices, self-plug here on our book, but Michael Nygaard's book, which actually predated microservices, so many of the founding principles are in there that it's really good. And I mentioned, I think building certain microservices, probably everyone's read Sam's book. It's really good. And Accelerate is the book I mentioned that does a real good breakdown of software engineering practices. It's from IT Revolution, Gene Kim's publishing company. If you know Gene from Phoenix Project. So that's it. I mean, what do I have? 30 seconds for questions. I can stay on longer, but at this point, I want to stop sharing so I can see people.
Yeah, I think just to respect everybody's time, we do have like a couple questions, but before we take that, I just want to do one small thing. Usually we do it Dallas Meetup. So generally we give away like vouchers for certification. This is to encourage people to get certification. So these vouchers are will help if anybody is interested in any new certification, they can take this voucher for instructor-led training. So generally the way we do is like we ask questions and people answer that and we give away to people who answer first. But since this topic is very different than what we would do usually, so I have come up with something. Let me share my screen. Let me know if you guys can see it. Yeah. So I know when I plugged in the names, I had like a few more participants, like 41 around. I guess few people dropped off. So we'll just do this. We'll run the wheel of names, and then we'll just pick 3 winners, right? So whoever name comes in, please either DM me or just put your email in the chat, and I will reach out to you for the voucher. All right, let's start this wheel.
Is this a website? Did you write this, or is this a publicly available website?
No, it's publicly available.
This is fantastic. I have a suspicion this will become a recurring thing.
Oscar.
Hey.
Do we have this person still? Oh, yeah. Hey, Oscar. Awesome. Congrats. Can you please DM me your email ID? All right. We have, I'll remove Oscar. I'll do it again. Oh, David. We have David. David is not there. So I'll have to do it again. Sorry, guys. Gerardo, do we have? Think no, we don't have this person. All right. Nope.
These names from all the.
I plugged in right before we started this thing. So I had like 40 people. So some people dropped off in between. All right, Sridhar is here. So one last thing. So one last name. We'll see. Abhishek is also here. So guys, please send me your emails and I'll reach out to you for the vouchers. And I know it's way past 3 o'clock. What do you guys wanna do? I just wanna respect everybody's time here. Do you wanna take question or should we move on?
I can take questions, and if people need to drop, then they can feel free to drop off.
Let's do 3 at least, Roman. The one thing
Okay.
I mean, this is why everybody's here. The main question everybody wants to know is GraphQL replacing REST anytime soon, Matt? Hey, I'd love to hear your perspective on this.
No, I don't think so. I mean, does anything ever get replaced? Like, I think people are still using SOAP, right? Maybe Corba's gone, but probably not. I think that GraphQL has just been. I've been a little bit cynical about GraphQL from the outset because it was so obviously marketed, right? It was so much. We're going to put out a spec. We're going to promote it. We're going to build a company around it. The funny thing is that the founders, the company they built, didn't really pan out. But I think Apollo is now big on it. But like, I mean, it feels very RPC-ish, right? When you use it, and I think that we're going to go. Maybe we're at peak GraphQL, and then there'll be the trough of disillusionment. I suspect people will become frustrated with having the consumers learn the schemas. I think that people will find that it's a little harder to do change management around it and supporting kind of ad hoc queries in the back end. So it'll show its warts, and then people will use it where it's appropriate and still use other things where it's not. I wrote a piece for InfoQ a couple of years ago actually about that. And I think one of the things that is actually quite spectacular about REST, or at least what we call REST in the industry, right, is how ubiquitous it became. And if you think about it, REST became popular as a reaction to SOAP. A lot of times that's the way things work in tech. We like this because we don't like that. Right? And so, but what happened is, RESTful APIs were so simple to use. They were kind of the means of, first of all, just integrating on the web. But then, can you imagine social networks taking off without RESTful APIs, or some of the bigger payments providers like PayPal and big public APIs? And then you had mobile. Like, we didn't have mobile apps, and then all of a sudden we had to start writing these things called mobile apps, and we needed a way to connect them to backend. So people who had been developing RESTful APIs over here could now jump into the mobile space and start developing things over here. So just the ubiquity of REST, forget all the technical value points, right? The fact that it was just this universal way of connecting things through web technologies makes it really powerful. And even, APIs for administrative systems, right? AWS launches, what are their APIs? Well, they're all RESTful APIs to do. So I think it will be a shame if we lose that sort of standard way of connecting things, because it becomes, then we get overly specialized in the industry. But anyway, I think right now I would look at GraphQL is typically optimized for JavaScript environments where they're supplying data to front ends. And in those environments, you typically have full stack developers, right, who might maybe own both the front end and the back end, so they can have the flexibility there. But in terms of GraphQL, I think we've already seen like GitHub and others who have tried to offer public GraphQL APIs have already started to hit some of the pain points that I think will be question marks around it.
That's a good point. I mean, as techies, we get excited about the shiny toy,
But it is shiny. Like, the blog I wrote, I wrote a GraphQL blog last year, or was it the year before? All the years blend together now. And it was far and away the most popular blog I've written, just because it had GraphQL in the title.
Maybe one last one, Raman. You want to pick a question?
Looking for the blog. All right. What's this? So there's a question regarding data sharing, microservices versus cloud-based data sharing model using SQL for outbound data sharing. Not sure I follow that question. Do you guys know what the person is asking?
Would that be, should I share my data sources through SQL, or should I put API encapsulation of a microservice around the data? I'll assume it's that. So, I mean, a pattern I've seen even in mature microservice environments is to kind of wrap the data in an API rather than open up SQL access to the data sources. And I think that, we talk about experience APIs, process APIs, system APIs. Look at that as kind of a subset of the system API layer in a lot of environments where people have said, look, we just want to make sure no one is connecting to our data sources directly. So it will be a better decoupling mechanism to put an API around it, and also avoid like stored procedure sprawl that can happen in when you're sharing data sources as well. So I think that's fair to say that's a best practice. Especially if you have data that's very widely shared across the organization, to put an API in front of that and handle access that way.
Yeah, I think the same person is asking, if you do data service virtualization using the view in Cloud DB, can this risk overcome?
Yeah, I probably would need to know more specifics about it, and probably would quickly be the wrong person to answer the question. But I would say there's definitely there's a reckoning coming for, as I mentioned before, the data world, where companies that are, and there's a lot of them that are building big data lakes and enterprise data layers, that in order to integrate that type of information into all the systems they're going to want to integrate it to, they need to be more distributed. And I think that's where the data mesh concept is coming from. But I think it's also where APIs are going to play a bigger role. So there's lots of ways to skin a cat. There's lots of ways to get shared access to data sources. There's lots of connectors and data virtualization platforms that will say, hey, we can spread the data everywhere and give you access. But I think that, again, it's going to come down to that affinity between your organization and how you work and deliver things, and what's actually implemented in the technology. And I think when that's a big consideration, we have kind of proven out the microservice approach, whereas there's just going to be problems of interdependency if you do things in a lower level way.
Maybe a last question is a plug for you, Matt. Can you tell us about what your current role is? How you help customers, and because this is a customer forum.
Yeah. So I mostly am working with companies and working with our awesome field team, helping them define API strategies and execute API programs. But that has a lot of meanings. That could be anywhere from a company who said, we want to go to market with a monetized API product. How do we do that? To a company that's saying, we want to be more productive and agile, and we want to use APIs as our default mechanism for integration, and everything in between. So that covers a lot of business strategy stuff as well as architectural considerations. And the best way to engage with me is to work with your local field reps in MuleSoft, and that way. I'll plug that Stephen Fishman and I just recently co-authored a marketing's calling it a white paper, but it's like 70 pages long. It's our guide to API product design and API product strategy. So that's downloadable now. Lots of stuff in there.
Okay, this link, maybe Ruman, we can include that part of the summary.
Yeah, I'll send the link.
Yeah, that would be great. Yeah, no, this was great. Thanks a lot, Matt, and thanks everybody for joining. I will send the video recording. I'll have to upload it, and so look out for my email in like next day or two. And don't forget, everybody, to register for our next meetup, which is next month. We'll talk about the roadmap on MuleSoft, so that will be exciting as well. So you'll get to see new features, what's upcoming in Mule. All right.
Awesome. Thanks for having me.
Thanks, Matt. Thanks for joining.
Bye-bye.